There are many things that cannot be explained in the visible universe, and scientists have they have added some additional quantities that are there in the universe, and these two important quantities are one is dark matter and another is dark energy. This dark matter and dark energy, they are two mysterious and elusive components that make up the majority of the universe's mass energy content, but do not emit light or electromagnetic radiations. So from the point of detecting them using any kind of detector, it becomes impossible because they do not emit light and they do not emit electromagnetic radiations. So, despite being invisible, their presence is inferred through their gravitational effects, and on which these gravitational effects are that's the visible matter and the large scale structures of the cosmos. Now, to start with the dark matter constitutes nearly 27% of the universe's total mass energy content. It was first proposed in 1930s by a Swiss astronomer, Fritz Zwicky. And when he observed the discrepancies between the mass needed to explain the motion of galaxies and the visible matter they contained. So this dark matter came up as a quantity that could compensate the dynamics that were being observed out there in the cosmos, in the universe. So nearly it constitutes 27% of the universe's total mass energy content. This dark matter is it's believed to be composed of non-baryonic particles. That means this dark matter, it's not composed of the matter, the visible matter that's out there, what is probably made up of protons, neutrons, and electrons. So the composition of this dark matter is is non-baryonic. It does not contain the particles like protons, neutrons, or electrons. And this dark matter, it does not interact with the electromagnetic forces. So this is another mystery. So it neither emits or absorbs, and maybe it does not reflect the light. So all of these things are making it invisible to the traditional telescopes, the telescopes that we have, which are very sensitive to electromagnetic radiations. For these traditional telescopes, anything that's out there from this dark matter is believed to be not detectable. This dark matter's presence, it's certainly inferred through the gravitational effects on the visible matter, such as galaxies, or there are clusters of galaxies, and even CMBR, cosmic microwave background radiations. And it's the gravitational pull is essential. And now the question is here that what is this pull? It's essential for the formation and stability of the galaxies and galaxy clusters. Without dark matter, galaxies would not have enough mass to hold together under their observed rotational velocities. So the connection between the velocities and the actual matter that these galaxies have, from experimental calculations point of view, they will not be in a position to hold such geometries, such motions, such velocities. So, uh, in order to compensate the observations, this component of dark matter is being addressed and introduced, and the exact nature of this dark matter remains unknown, and scientists are trying, searching for dark matter particles. In fact, they are using experiments like LHC, Large Hadron Colliders, and some underground detectors. Now, the next part that's out there is the dark energy. This dark energy accounts for approximately 68% of the universe's total mass energy content. So, see, its percentage is very, very large in comparison to the dark matter. If we make the comparison between dark energy and dark matter, they are making up most of the space that is enclosing the visible universe, because we may not be in a position to explain the dynamics of the universe out there without assuming the presence of dark matter and dark energy. And this dark energy, it was discovered in late 1990s, through observations of distant supernova by two independent teams of astronomers, which reveal that universe's expansion, it's not only expanding, but it's accelerating. Unlike dark matter, dark energy is not a substance. It's not or particles, but it's a kind of mysterious force, and it's a force that pervades space, and it's a force that drives the accelerated expansion of the universe. If we go back to the observations of Edwin Hubble, the outcome of those observations was that the universe is expanding, and it's expanding at alarmingly very, very fast rate. And in order to compensate that, there is an energy available in the visible universe, and that energy is the dark energy, and this dark energy is, it's not made up of particles, but it's a kind of mysterious force that's driving, that's accelerating the galaxies and the cluster of galaxies away from each other. And this dark energy, it's a repulsive force, basically, that counteracts the attractive force of gravity, and causing these galaxies to move away from each other at an alarming increasing rate. So the force that we are trying to intuit with the dark energy, this force is the repulsive force, and the nature of dark energy remains one of the most significant unsolved mysteries in the modern cosmology. It is often associated with the cosmological constant that was introduced by Albert Einstein, a term he introduced in his equations of general relativity, to allow for a static, for a universe which was assumed to be at rest. Understanding this dark energy is crucial for predicting the ultimate fate of the universe. So, depending on its properties, the universe could continue expanding forever, as it currently appears to be doing, or experiencing a big rip, tearing apart all structures in the cosmos. Well, both dark matter and dark energy, they remain enigmatic problems. Their influence on the universe is undeniable. Whatever their format is, certainly they are there. Cosmologists and astrophysics, they continue their studies, and they try to explore these mysterious components, and trying to gain the deeper understanding of the fundamental forces and the processes that govern this cosmos. As we unlock the secrets of dark matter and dark energy, we may be closer to unrolling the mysteries of the universe and our place within it.